Uh, presentation is on wireless in agricultural environment. What will maybe interest you a lot is how you could use the type of technology we're using with the Mikrotiks for something else, another application, maybe industrial or something else. So a little bit about us. I'm part of three companies. The one is Communet. It's a ISP in Pretoria. We run solely off Mikrotik equipment. We refuse to use anything else. And then there's DIMSA. We write software, custom software for tracking and tracing of assets, animals, livestock, that sort of thing. And then Matrix RFID. We, in that company, create custom software and hardware and electronics that integrate with the whole grand scheme of things. So I'll show you a bit about what it's about. And basically, we cover most of the larger feedlots and agricultural sites throughout the country. We hook them up with wireless networks that cover the entire feedlot area. And we also do different things with Mikrotik routers that other people maybe just use it for wireless. We actually use the Mikrotik routers as sensors and as devices to hook up to other sensors and stream data and serial ports. And so we connect them and actually use the Mikrotik itself as a device to do our work rather than having custom hardware developed for that. And we can do that because the Mikrotik is so open-ended to you editing it and writing scripts and changing almost anything you want in a Mikrotik router. So some of the things that our clients do is they have cell phones that they roam around on their property and make phone calls with WhatsApp and so on, where there isn't normal coverage from cellular towers. Okay, so this is like a little example of, you can see the Omnitrix here on the side of these vehicles. And what we do with those Omnitrix is it provides a wireless connectivity for the computer in the tractor, and it allows it to ride around and be mobile. Wherever it goes, it's got connectivity. So how we accomplish that is we actually build WDS Mesh, because for us the throughput is not so important. We're not looking for high speed, we're looking for a large coverage area, a lot of connectivity, high connectivity, and obviously with it being mobile, these things ride around in a large area and they have to be connected wherever they go. So how we do that is with WDS nodes, and the WDS works really nicely to allow a smooth handover and switch over. I mean, we've even got WDS nodes where you can walk around with your cell phone, make a VoIP call, and it'll hand you over one WDS node to the next without even dropping a call. So in this example here, you can see we've got about 15 nodes in WDS, and we have to configure them in a static partial mesh because a full mesh just wouldn't work. There's too many nodes, and if they all just connect to each other, some of them signals will be very poor and it'll just create chaos. So we have to create a partial mesh out of the WDS. Now, how it all works is we've got front-end loaders or machinery that's got tablets inside, and that tablet's got 5 gig Wi-Fi, and it connects straight up to Omnitrix in WDS. It then has the data then gets streamed from either a static mixer or a one that's moving around, and data from the scale on these vehicles gets streamed directly out of the Omnitrix to, well, we make a TCP socket connection, and the software makes the connection over the network and streams data straight to it. So we use a USB to RS-232 converter, and we'll show you an example of how we do that. And you can just hook up this USB to RS-232 converter straight into any Mikrotik that has a USB port and allow remote access, and then you can connect straight to the router. So here's an example of him busy loading, and as you can see, it's all wireless. He's got a tablet inside his cabin. It connects to, there's an Omni on the top of his roof, and that will connect wirelessly to the infrastructure on site. And same for this Omni connecting to the WDS network, streaming the weight off of this vehicle straight onto the tablet with pretty much no other hardware than just a Mikrotik and a USB to serial converter. Okay, so just to show you how we set up the WDS mesh. WDS is pretty old and standard protocol for Mikrotiks, and we use it with great success, but obviously you have to set it up right. And so the things to look out for is all the nodes have to have exactly the same wireless setup. So you have to set up the same SSID, the same frequency channels, same modes, same passwords, and then you just go to WDS and you set it either as a dynamic or static mesh. When you set it as dynamic mesh, pretty much it will automatically register and create here a WDS interface. And those WDS interfaces will be created dynamically. So if you add a new node to the system, it will automatically create a link between the two WDS APs. But what we want is a partial mesh, so we don't want all of them to connect to all of the others. So how you do that is you first set up a dynamic mesh, you get them connected, then you choose the ones that have the best signal strengths, and you basically click on this WDS that's been created dynamically, and you choose to copy it. Once you copy it, it will change from this dynamic one to a RSA, which is it's not dynamic, it's basically static. And then you can change your WDS mode from dynamic mesh to static mesh. And once you change it from dynamic mesh to static mesh, it will only connect to the APs that have been copied statically, otherwise it won't connect to the others. And that will allow you to create a partial mesh structure like we've got going on here. Yeah, we've got 10 or 12 nodes connected, but because of where they are in relation to each other, some of them don't have good signals if they connect directly to all the others. So we only choose the ones that have really good signals, and that makes the whole network more reliable, faster, the pings, latencies are lower. So on a network like this, even with WDS running with 15 odd nodes, we can get 6 millisecond pings pretty consistently, no matter where you go. And these vehicles are driving around, moving around mobile, switching from one node to the next pretty much seamlessly because of the WDS. Okay, so here's some pictures of how tough Omnitrix can be. We've been really surprised how strong these things are. These have been running for 3 years in the rain, outside, being bumped and scraped and scratched, and they just keep going. Sometimes our clients come to us and say, oh, this unit's broken. We go and look and there's nothing wrong with the unit. That's 9 times out of 10, the unit is fine. Okay, so to do the streaming that we're talking about, we've got a USB to serial converter. That's these little chips over here. And that will just take your RS-232 levels and turn it into USB signals. The types of peripherals that are supported you can find on Mikrotiks wiki. But we use the CP2102 range. You can also use FTDI's USB to serial converters. You just plug them in, drivers are automatically detected, and there you go. So to set it up, I'll do a demo, so I won't run through this too much, but you basically go to IP server system ports, and then under your ports you'd see that it would have detected the USB that you've plugged in. You then set up the baud rate, That's kind of like your RS-232 stuff. And once you're happy with that, you set up under the remote access tab. You just choose what port, TCP port you wanted to operate on. Now, what that will do is basically take the USB stream or the serial port that you've got and turn it into a TCP server that you can connect a TCP client to. So once you make a TCP client socket connection, it's a pipe that you can communicate, talk through. Okay, so I will show that to you now. We've got a little demo here in the front with a scale connected to this RS-232 to USB converter, and that's plugged into, well, a router there. And to show you how that will operate, let's just open up the router, and you can see here we've got the port, and it's set up standard serial port. You then go to your remote access, and then in the remote access you can choose, are there certain addresses that are allowed to use it, what channel is it on, what's the port that you're going to expose the socket on, and if you want it to be RAW or RFC 2217. I pretty much just use RAW most of the time. This will allow us to connect. You can also have USB to serial converters that have more than one port or channel, and that's where you'd put this channel in here, so you could choose from one converter to run multiple serial channels and expose them on different comp or different socket ports. Okay, so when we connect to this thing, you'll see, we'll just go to RAW. Once we connect, the remote access will actually show you that you are indeed connected. As you can see, there's some weights coming in there. Yeah, and so we're basically streaming live data over the network, and on your software side, you just have to make a TCP socket that connects to that, and then you can make your communications happen. So there's many applications you can use this in, and it's kind of up to you guys to come up with maybe some more ways we could use this feature, because I think it's a bit underutilized in a Mikrotik. What we use it for is streaming data like this through a scale. We also have scanners that scan RFID wirelessly. It's being operated through the same USB to serial port, and relay boards and controllers for inputs and outputs, that sort of thing. Okay, so one problem that we do face with this technology is that you get a thing called a half-open TCP connection. And how that comes about is you make a TCP connection, but because these units are mobile and they're driving around, they sometimes go out of range. And then the wireless will drop, but the connection is still opened. And so on your client software, you usually know the connection's gone, and you retry and you make a new connection. But on the server side, or which is the Mikrotik side of it, it doesn't know that that connection is invalid. It's still got the connection opened. And so if you try to open the connection a second time, it doesn't allow you to connect. So you have to forcibly somehow close that half-open, stale connection before you can connect a second time. So we've done that with some Mikrotik scripts, just disable the port and enable the port again, and that usually resets it, and then you can connect again. Okay, so we're still very surprised at how tough Mikrotiks are. On the left, you can see there's a truck. The bracket was made out of aluminium. Then what happened is the truck rode, and the Omnitrix actually caught on a roof, and the metal bent, but the Omni didn't have any damage whatsoever. It just survived. So that just proves that Omnitrix are stronger than steel. And so are we. our one guy, he's sitting in the back there. Bayer? He's not sure. We were in Ethiopia and there's no ladders available, so we are tough and we make a plan. So he climbed up on a guardhouse on top of a front end loader. As you can see, it just wasn't quite tall enough, so he proceeded to take a big steel ladder and put it on top of the guardhouse and climbed up there. Yeah, this looks brave, but we got the job done, so that's, I think, the main point. So this is our relay board, and it's just a USB that you plug in, and it allows you to connect, like we just spoke, with the socket. You can connect to it and control relays and inputs and outputs with that. All right, and that's about it. Thank you. Any questions or comments? Yes. Yeah, no, we make this ourselves. The guy sitting there, put up your hand, Ben. He makes the boards. So I'm sure he can supply you with some if you want them. Yes. Okay, this slide, yeah. We use a program called Radio Mobile. So I'm sure some of you are using it or have used it. You use Radio Mobile, it's free software that you just install, and then you get satellite digital elevation models, which is the satellite imagery for the height, and then it actually plots and paths. That's a simulated beforehand, but we're quite good at our plots. We've tested them, and almost all the time the plots, what you see in the plot is what you actually get out in the field. Yeah. Yes.
The modeling has been done for decades, starting with people in the field making radio measurements and then reducing them to equations. And when I first worked on them, it was before they were computerized.
Okay.
So they've been tested extensively.
Yeah.
But this makes it painless and brainless.
That's true. I mean, it is a mathematical formula you could follow, but to go and point out every point would take you forever. So.
It's called Longley Rice, and it's named after the people who started doing it.
Yeah. All right.
Very thick paper.
Yes.
The TCP server, does it just handle one connection and then blocks all the others?
Yes, that's exactly what we've seen it doing, and that's kind of our problem with it, is that once you've opened a connection, you have to close it off properly. Otherwise, the Mikrotik will still think you've got a connection open. There are cases where it closes nicely, but if you, for instance, connect it and you just go out of range, then on the server side it stays connected.
Surely that's a wonderful feature request that we could ask for.
Definitely. If all they need to do is that if you connect the second time, it must throw away the first connection and just accept the second connection, and then that problem will be sorted.
Anyone second that?
Yes. Yes. Definitely. Yes, back there.
So you say you had a thing where you just had a report to rename that to get the socket to drop.
Yes.
Just an idea, if you had another script on there that would pick up all connected sockets and start pinging said host. Now that the host stops responding, automatically clear your connection.
Yeah, it could work depending on the application that you're using it for. In our sense, it has to be live, and because the stuff's mobile, they do get disconnected sometimes, and they do time out sometimes. And so we don't want to force the connection to close if it can recover, because a network like a socket can stay open even if you're disconnected from the Wi-Fi. The socket can stay open. If you come back in a reasonable amount of time, you can still send data through the same socket again. So what I do is, I'll just show you. I'll go port. We just basically disable the port. Or was it under remote access? See, once we disable that, it goes invalid and it will come back. And if there was a connection that was connected, once you've disabled and enabled it, it will be gone. Yeah. Yes.
Why do you make your own relay board rather than purchase one?
Because of our own requirements we had for it. We need.
Are there relay boards that are available that might be suitable?
I guess not. Not. You don't just get a relay board with a USB to serial attachment to it. So I guess if you can get the USB to serial part separate, you could attach almost any serial device that you want. If it's a relay board or any other device, as long as it's a serial device, because you're going to control it with your software through the socket at the end of the day. Yeah. Any other questions? All right. Thank you very much.